All right, so let's run through the lesson a little bit here. We have this scenario where there's a pool ball that's shot and it moves directly towards this 8 ball, or I guess a little above it because it's going to go off at this angle here. And the whole gist of this lab is that momentum is conserved in both the x and y directions. So we treat them independently just like we do projectile motion. So suppose a cue ball mass ½ kilogram is moving in the positive x direction as shown in the picture above with a velocity of 3 meters per second. What's the total momentum in the x direction? Well, momentum is mass times velocity, mv, and so in the x direction this is 3 meters per second times ½ a kilogram, which is 1.5 kilogram meters per second. Is the total momentum in the y direction? It's 0. Right? And it says explain, there is no velocity in the y direction. Velocity in y is 0. What will the total momentum be in each direction after the collision? Well, since momentum is conserved, the total momentum in x is unchanged by the collision, so 1.5 kilogram meters per second. And in y, the total momentum is still 0. Doesn't mean individually the pieces aren't moving. It just means that they will sum back to 0. So 2, after colliding, the 8 ball moves in the direction shown with a velocity of 1.31 meters per second. What is the velocity of the 8 ball in the x direction? Well, I'm going to go ahead and draw this. The 8 ball is moving down this way. And this angle right here is negative 40 degrees. Now, I said negative 40 because it's measured down from here. I could measure it this way and it could be 320, but it is important that we see that that component in the y direction is negative. Anyways, it tells us that this velocity is 1.31, and then if I draw in a component of this, then what I have is the velocity in y, and I have the velocity in x, right? And now I have a right triangle, and so I can say, oh, well, velocity in the x direction, vx, is clearly just v cosine negative 40. And if I do that, I get 1.31 times the cosine of negative 40, which is 1. The negative doesn't affect that at all because we're in the fourth quadrant and cosine is positive there. So Vx cosine of negative 40, and so this is 1.41 or 1.31 cosine negative 40, which is 1 meter per second. And this is what is the velocity of the 8 ball in the y direction, including sine. And so I will do the velocity in y is v sine negative 40. And when I do that, I get 1.31 sine negative 40. And that gets me negative 0.726 equals negative 0.726 meters per second. And it is negative because it is moving in the negative y direction, right? And I said positive if y is up. And then it says, what is the momentum of the 8 ball in each direction? Well, since momentum is just mass times velocity, the momentum in x is mass times velocity in x. So this would be 0.5 times 1, which is 0.5 kilogram meters per second. And momentum in y would, of course, be 0.5 times 0.726, which is 0.363 negative 0.363 meters per second. What must the momentum of the cue ball be in each direction? Well, the momentum in x was 1.5, so I have to have 1.5 is equal to 0.5 plus momentum in x of the other ball. That tells me the momentum in x of the other ball is 1 kilogram meter per second. And then it says in the y direction it was 0 to start with, and now I have negative 0.363, and so plus momentum in y of that other ball, and so that implies that the momentum in y has to be positive 0.363, so they add up to 0. And then it says determine the magnitude and direction of the cue ball's momentum. All right, now I'm going to draw another triangle. I have its momentum in x is 1, and its momentum in y is 0.363, and so its actual magnitude and direction is at an angle here, right? So I actually need this side of the triangle, and I'm going to use Pythagorean theorem, right? 1 squared plus 0.363 squared. And so square that, add 1, square root it, and we get 1.06 1.06 meters per second, and then I need that angle, and to find that angle I'm going to use the arctangent of opposite 0.363 over adjacent 1. So second tangent on my calculator, 0.363, and that's 19.95. So theta equals 19.95 degrees, and so I would report this momentum as 1.06 kilogram meters per second at 19.95 degrees.